Alright, so today we're going to be talking about neutralization reactions and titrations. So with a neutralization reaction, basically all we're talking about is that when we combine an acid and a base, we're always going to get some sort of salt and water, okay? So our products will always be a salt and water. And sometimes the salt will have a neutral pH, but sometimes it'll have a pH that's a little acidic or a little bit basic. So how do we know? How we know is we look at these original acids and bases, okay? If this is a strong acid and this is a weak base, well, the salt's going to be a little acidic, right? If this is a strong acid and a strong base, it's going to be neutral, okay? Think about like a tug of war, all right? So we're going to walk through a couple of the different situations so that you can understand how the salt is going to either be basic, slightly acidic, or a little bit more neutral, all right? So I have a strong acid and a strong base. I'm going to be neutral. So this is going to be the salt over here. The salt that's produced is going to be neutral. Okay, if I have a weak acid and a weak base, it's also going to be neutral. So neither one is going to overpower the other. They're going to neutralize each other. All right. Here's where it changes. I've got a strong acid with a weak base. Well, the strong acid, it's going to make the pH a lot closer to an acid. So this is going to be slightly acidic. All right? And then if I've got a weak acid, but this time with a strong base, well, it's going to be more basic. So it's going to be more slightly basic. All right? And that should make sense to you if you think about when you're combining either a strong acid or a strong base, weak acid, weak base. So what a titration is it's a way we measure volume to determine the point at which a reaction is neutralized, okay? So how much acid do we need to add to this base till we have a neutral solution? How much base do we need to add to this acid to be a neutral solution? And so we measure that in terms of volume, okay? And so how do we know when a neutralization has occurred? Well, that's when your moles of acid equals your moles of base. All right? And practically in the lab, we use indicators to help us identify that. Indicators. Sorry. That's an A. All right? So the key to understanding titrations is knowing that your moles of acid has to equal your moles of base at this point. You can have different volumes, but you have to factor in those concentrations. So really what we want to know is what are the moles of acid compared to the moles of base. All right, so when we go into the lab, we got to make sure we know what we're talking about, okay? So let's label some of this setup. So first, we've got our ring stand. All right, that's this setup, all right? And attached to it, we've got a burette clamp. Okay, it is holding a burette, not a beret, a burette. So B-U-R-E-T. And what you can notice is it's kind of like a graduated cylinder because it's got little marks that show us the liquid. But we'll notice that 0 is up here at the top because we're going to fill it up. And then we're going to turn this valve, the stopcock, and the liquid is going to go down. Okay, it's going to drop down into here. All right, so we're going to measure how much gets dropped down. All right, so it works the same as a graduated cylinder, but a little bit different. It's got those graduated markings, but you have to pay attention to how far you start and where do you start off with. Okay, so that's your burette. Here we've got our Erlenmeyer flask. E-R-L-E-N-M-E-Y-E-R. Sorry about those E's. And that's an Erlenmeyer flask that we're going to be using. And so you'll notice what we're going to do is we're going to start out with some acid in here that we don't know the molarity of. Okay, so we don't know the molarity of this. We're going to put base in here that we do know the molarity of. Okay, say 1 molar. That's what we're going to be using for lab is 1 molar. And what's going to happen is we're going to be able to calculate how much what the concentration of the acid is based on, well, how much do we start with? Well, maybe we'll start with 50 mils, okay? We can calculate this concentration based on how much of the base we end up adding in, all right? And we're going to use an indicator that will change colors that will tell us that the moles of acid equal the moles of base, all right? So, just like we said, we've got our base that we've got a known concentration of. In our lab, we're going to use 1 molar. And then we're going to have an acid of unknown concentration, which is really what we're looking for. All right? And then what we're going to do, we're going to see where we start out with. This is going to be our initial reading. And then we're going to add until we get a pink color for our phenolphthalein. Okay, and phenolphthalein is the indicator that we're going to use. And it goes from clear or colorless all the way to pink. So as soon as it turns pink, that's when we know moles of acid equal moles of base. All right? So we're going to use these volume measurements, all right, to help us determine what this molarity is. All right? So we do need to know the known volume. So this has a known volume. We know the volume of each. So when we do these, we're going to be able to see a titration curve. And basically what we can see is this is, as we go this way, we're adding more base. And you can see the pH is not changing that much. And then, oh my goodness, this spikes up. So at about 6, it starts spiking. And then it evens out about 12 for this particular titration curve. So what this tells us is halfway between that, at 9, we have what we call the equivalence point. And what that is, you guessed it, where moles acid equals moles of base. All right? So you'll notice that for this particular situation, it's at about 9 of pH. It's not always going to happen at a pH of 7. All right? So you have to pay attention to that. So here's calculation of how we're going to do it. If your moles of acid equal your moles of base, we're going to use this formula right here. MaVa equals MbVb. And this looks very similar to another formula that we've used before. M is going to be your molarity, and V is going to be your volume. Okay? So if it takes 25 mils of 0.5 molar HCl, well, that's HCl, so I know that's the molarity of my acid, and this is the volume of my acid, to neutralize 345 mils of NaOH. Okay, that's going to be my base, so that's the volume of my base. What is the concentration of the NaOH? All right, well, I'm going to start by rewriting my formula. MaVa equals MbVb. All right, so the molarity of the acid is 0.05 molar, and we're going to multiply that by the volume that I have. And you can convert this to milliliter, can keep this in milliliters, or you can convert it to liters. I like to use liters just for consistency, so I'm going to use liters. And then I'm going to equal molarity of my base, which I don't know, that's my variable I'm looking for, times the volume of my base, which I do know. Again, I'm going to convert that to liters, divide by 1,000 in order to do that, okay? And I get 0.345 liters, all right? The molarity of my base can be found once I multiply 0.05 and 0.025, and then I divide by 0.345. All right, so what we get is 0.0036 molar, and that is the concentration of my NaOH solution. All right, and that's it. So you guys have done similar calculations like when we did dilutions. So the math is the same, it's just applying the concept, and really this key concept is moles of acid equals moles of base. that will help you be able to do your titrations. All right, nice work.